Okay, welcome to the robotics class. In this very first class of robotics, we are going to learn about electricity, okay? So, this is a battery and this is a battery box. Well, you may have been used a lot of electrical devices like a lamp, a fan, or which they are battery powered, okay? You put in a battery and things work. Say I have a battery pack now, and I have two wires coming out from the battery pack. Okay, so let's see. Okay, the LED is being light up. Okay, the LED is being light up. So a battery powers up an LED or whatever device that we are going to use. Okay, so how does a battery work? Okay, when you look at the battery, of course, you know there's a positive side and there's a negative side. Okay, positive side and a negative side. How does it work? Okay, how does a battery work indeed? Why we connect a battery? Why we connect two sides of the battery to a light bulb and it will light up? Well, it have to be. Let's look at the composition of a battery. Okay, a battery on the positive side they have cathode, and on the negative side they have anode, and they're separated by the electrolyte in the middle. So what exactly happened when we connect it to a light bulb like this? Okay, when we connect the positive and negative with a device in between, this circuit, this is a what we call a circuit. Okay, and when the negative side of a battery have access to the positive side, then we call this a closed circuit. Okay, a closed circuit. Okay, a closed circuit is when when there is wiring that wires up the negative side of the battery to the positive side of the battery through some devices. Okay, because inside the battery, the positive side and negative side, they are not connected. They are separated inside, and they can't travel through. They can't connect through inside. Okay, so what exactly happened in the battery? Actually, in the anode, there's a lot of electrons. Okay, there's a lot of negative electrons that are flowing around, that are congested in the negative side. Okay, all the negatively charged electrons. Okay, we have, like, for example, we have 20 electrons here where we have no electrons here. Okay, so if we build a circuit that connects the negative to the positive, the electrons will tend to flow to the positive where there's less electron, because the electrons will flow from the congested area to an area that is less congested. So when this circuit is connected, electrons will start to run from here to here, passing through the device that we built along, and go to the positive side, and some chemical reaction will take place, and the electron will merge with the chemicals in positive side. Okay, so in this way, there are chemical reactions that are going on in anode, which is the negative side, and then that produce free electrons that roams around, and because there's a higher concentration of electrons in the anode than the cathode, so the electrons will pass through the wire, and when the electrons go through devices, it will produce power to the device that powers the device, and that's how you get power. And eventually the electron will go to the cathode and be merged to it. That's why, because there are chemical reactions here and here, that's why one day the chemical reaction will be completed for all the substances in anode, and that the electron will transfer to cathode. That's why a battery have its battery life and it have its capacity. Okay, is when all the electrons are used up in anode that are being passed to cathode. Okay, so this is a closed circuit. So if somewhere you connect the anode to the light bulb, but not the other wire, this will not be a completed closed circuit. This is still an open circuit and the light bulb will not be light on, okay? The light bulb will only light on when you connect the light bulb to both cathode and anode, okay? So look, I have this battery pack. Okay, it's just provide me convenience so that I don't have to press on the positive and negative sign, okay? So if I connect it here, okay, if I connect here, if I connect one of them, it doesn't power up, okay? If I connect both, it powers up the LED and lights it up, okay? Same way as the motor, okay? Same way as the motor, okay? I have a motor, okay? And I can connect both, okay? Okay, so, but you can see, okay, so this is how it goes, okay? We connect it, and there's a fan, okay? So that's how things work, okay? Well, of course, we don't want to like hold the wires all the time. So I'm going to introduce you this thing, okay? This long board with a lot of holes, okay? In this class, you will work closely with this thing. And this is what we call breadboard. Okay, breadboard, okay? This board, okay, like a bread, okay? So how does a breadboard work? A breadboard is there, so let me demonstrate the example, okay? I have the battery. I connect this to here, and I connect this to here, okay? So, and then I can just connect the LED and it powers up, okay? So how does it work? Okay, as you can see, so the breadboard actually works in a way that we can just, you see, all the wires and the devices, we have pins. We can just put pins into the holes. But what is the magic and how does the holes being connected? Okay, so we look at this, okay? We look at this. On a breadboard, horizontal holes are linked together, okay? But not cross the middle divider. So which means when I look at the breadboard, when I hold it in this way, okay, this A, B, C, D, these five holes, they are connected together, okay? And then the next row, these 5 holes, they are connected together. And the third row, these 5 holes, they're connected together. But vertically, this hole and this hole, they're not connected, okay? This hole and this hole, they're not connected. But these 5 holes, they're connected. These 5 holes, they're connected, okay? This is the way that we work. So if we connect it here, and if we connect it here, if we connect the LED to these 2 rows correspondingly, then we can power up the LED. See that? Okay? So, as in line with that. Okay, so in the middle part, we know how the hose being used. How about at the sides? I have a positive line and a negative line. What is that? Okay, look, vertical bus stops are continuous down. Okay, so which means, okay, if I'm going to build a very complicated device, and I'm going to need a lot of power, a lot of devices are needing power, I can essentially put this here and put this here. Okay, I put positive and negative here. So what next is I could connect this positive. Okay, look, I can connect this positive. Okay, let me go down a little bit more. So I connect the battery to these 2 different lines. Okay, you can see since they're connected, so I can connect from here. I can go from here to here. Okay. If I have the LED here, okay. And remember, the LED also have a positive and negative. You see an LED have a longer leg and a shorter leg, okay? The longer leg goes to the positive and the shorter leg goes to the negative. So since I'm building a positive here, I'm putting the LED like this, okay? And then I'm going to connect another cord from this row. Any point would be fine. To the negative, see when I connect any hole in this row, it will power the LED. See that? See how the breadboard is working? So at the side, the vertical stripes, they're continuous, they're all connected. In the middle, they're horizontally connected. So this is how we use a breadboard, okay? So, well, and then next, okay, let's go up. Next, okay, we're looking at, okay, when we say the LED have a positive and negative side, right? So the positive and negative does matters because it's one directional, okay? If I connect the LED correctly, positive to positive, negative to negative, the LED lights up. But if I inverse the positive and negative and I put it in, the LED does not light up because it's one directional. The LED is what we call light emitting diode. It's a diode because it's a diode. Okay, it's called light emitting diode. Because of its one direction, so you can only connect the positives of your power supply to the longer side and the negative to the shorter side, okay? So this is a little bit special for LED. So what if we have a fan, okay? We have a fan. So let me put a paper, okay? Let me continue to use this as an example. Okay, so I'm going to connect the fan and connect it to the power supply. Let me make it a little bit easier. Okay, I'm connecting the fan to these two row power cord directly. Okay. Oops. Okay. So the fan, either if we connect it both sides, it works. Okay, you can see. Okay. I connect it, it works, right? What if I put the gray cord as the positive, right? What if I invert that? What if I invert it? It also works. So what's the difference? So let's try, okay? First, let me put the gray as the positive. Okay, so I put the paper here. Okay, it blows it away. It blows things away. Okay? So what if I change the gray cord to negative? It doesn't blow. Instead, you know what? When I turn around, it blows from the other way around. Okay? It doesn't blow this way. It blows the other way around. Okay? So, which means, for a motor, if you connect it in one direction of the positive and negative, it blows one way, it turns one way. And if you connect it in another way, it just turns the other way. Okay? Okay? So, when you are wiring devices like a motor, you also have to be paying attention which side you are wiring and which direction the motor is turning. Make sure you have the fan. Okay? Okay, so this is the positive and negative. Okay, so right now, okay, I'm going to introduce you something else. Okay, there's a lot, but this is also essential. Okay, I'm also going to go with you about current. Current. Okay, current is a very important concept. Okay, because if you just connect a LED directly to a battery, it does not do very good with the LED. It will essentially burn the LED. Actually, what you need is you actually need something like this. Okay, a tiny thing. This is what we call a resistor. Okay, a resistor. We need it in between the LED and the power supply. Okay, if I put the LED here, I will be putting it here and here. Okay. Okay, so I'm going to connect the positive. Okay, and I'm going to connect the negative as well. Okay. Okay, so we actually, for anything that you're going to put in, you actually need something like this, the small thing here. Okay, this is called a resistor. Okay, this is called a resistor. Okay, so why? Because for each battery, right now the battery is 1.5 volt. Okay, 1.5 volt. Okay, so for each battery except for the volt, we also have, this is the voltage. We also have the current. Okay, voltage is measured by how many electrons that pass through the circuit in a specific time frame. Okay, well, when we say about voltage, this battery is 1.5 volt and your power outlet is 220 volt, if you have noticed that. Okay, and current is how strong is the electron producing power. Okay, voltage is the number. Okay, number of electrons. Voltage measure the number of electrons, and current measure the strength of electrons. Okay, the current is how strong it will produce power. Okay, so without a resistor, the battery will give as much current as it is. Okay, more about this will be on the reading. And so we need a resistor to turn down the current. Okay, we need a resistor here in between to turn down a current. So we'll learn more about that later on, but right now just pick up a random resistor that you can have and put it on and power up the LED. Okay, okay, so and another thing is, okay, so another thing is, okay, this is another device, electrical device. This is a button. Okay, so when we do breadboard, I mean, we don't want the LED to be always on, right? So we want it to be on only when we press the button. So how do we do? You see these few little legs. Okay, I'm going to put it in the middle of the here. Okay, so as we see, the legs are across the river. Okay, so as we say before, this left side and this right side, they are not connected, right? So when you press the button, it will connect these two sides. So how are we going to rewire that? We are going to rewire this here. Okay, the negative side to this side of the river, and the positive side to this side, and we are going to continue. We are going to build it almost the same, with exception that we put it across the river. So the negative is up. Not this. Okay, here. Okay, let's see. Let's put it this way. Okay, so it will actually connect these two. Okay, it depends on which leg you're using. Okay, so we connect the positive to here, to the resistor. The resistor goes to the LED, to the positive side, and the negative side of the LED goes to this push button, and this push button, the other leg goes to the negative. But right now, these two are not connected. These two will be connected only if you press the button. You see? Okay. So here's how it goes. You press and it turns on. Okay? Okay? Okay, so, oops, that's why we missed it. Okay? Okay? So, this is how we do basic breadboarding. And today we learned a lot of things. We learned what is breadboard, which is this board, and how does the breadboard connect. What is closed circuit, which means a complete circuit from positive to negative. You can see when we trace this all the way, and eventually we'll find the path back to the negative for the power. Okay, and LED is this thing, and we learn about voltage and current, and the battery is being powered using electrons. Okay, so that's all for today.